Plunging into the vessel space there is an additional planet called Proxima B that has a cosmetics basically the same as Earth and is situated in the livable zone of its star Proxima Centauri. This star is eminent for being the nearest star framework to our own after the Sun. This red small star is arranged 4.23 light-years from our Sun, making it an intriguing objective for galactic investigations the way that Proxima B has conditions looking like those on Earth quest the premium of researchers and fans the same as of late. Progressions in innovation, especially the new James Webb Space Telescope, have empowered stargazers to distinguish lights radiating from the exoplanet Proxima B. This disclosure could act as unquestionable proof that the planet is possessed by extraterrestrials, touching off fervor and interest in the conceivable outcomes of life past our planet. Anyway, this finding is only one of the various invigorating revelations that the James Webb Space Telescope could offer us as we investigate what our new telescope might uncover on Proxima B. It brings up significant issues about the practicality of sending a manned mission to this far-off exoplanet. Stay tuned as we dive further into this puzzling disclosure by the James Webb, assuming that you're energetic about staying aware of the most recent improvements known to man and its hoard pond. Consider buying into our station. Remember to like this video and turn on the notice ringer to remain informed. Now, what precisely is an exoplanet? An exoplanet is characterized as a planet that circles a star other than our Sun, which implies it exists beyond our planetary group. Among the exoplanet researchers have been exploring, none have drawn as much premium as Proxima B. The star related with this exoplanet, Proxima Centauri, is named a red diminutive person, portrayed by its moderately cool temperature of 2,872 Da. It is fundamentally less monstrous than our Sun and transmits something like multiple times less light. The vicinity of Proxima B to its star is urgent on the grounds that it exists in the tenable zone where conditions might be reasonable for life as far as we might be concerned. This zone is normally where fluid water can exist on a planet surface, a vital element for life. Proxima B has highlights that are surprisingly Earth-like, including land masses, seas, and possibly even life itself. The presence of auroras could give the planet a greenish tint in its air, coming about because of extreme flares transmitted by its star. These heavenly flares establish a complex, attractive climate that could encourage novel air peculiarities. Strangely, Proxima B is clean-locked, meaning a similar side of the planet generally faces its star like the way that our moon circles Earth. This outcomes in a strange place where conditions may be better for life. The surface temperature on Proxima B could go from 90 degrees Celsius to 30 degrees Celsius, established a wide cluster of conditions. Finishing one full circle around Proxima Centauri takes roughly 11 Earth days, demonstrating a lot more limited year than we experience on Earth. Also, Proxima B has a gravity that is around 1.3 times more noteworthy than that of Earth, which would have suggestions for any potential life frames that might foster there. Anyway, researchers stay dubious about the specific idea of Proxima A's air. Assuming it exists, it might contain fundamental fixings, for example carbon dioxide, different minerals, and water, all essential for the biochemical cycles important for life. Regardless of the fervor encompassing Proxima bending man missions, there stays a huge test because of the tremendous distance included by a venture known as Advancement Starshot is a work in progress upheld by tycoon Yuri Milner. This task intends to make nano-tests fit for going at 20% the speed of light. These tests would be intended to visit Proxima Centauri, offering an uncommon chance to concentrate on our adjoining star framework very close. The proposed speed of these nests is around 16,000 kilometers per second, which would permit them to reach Proxima Centauri in years and years. Such a mission could give priceless experiences to people in the future, opening mysteries about Proxima Centauri and its fascinating exoplanet Proxima B. So what could these nano-tests uncover when they at long last show up? Strangely, we have proactively started getting signals from Proxima Centauri. These transmissions were recognized by the Park Radio Telescope during examinations concerning the star, which was discharging areas of strength for bizarre light that caught the consideration of space experts, including Anderson from the College of California, He drove the Advancement Listen project, which intends to look for mechanical civilizations in space facilitating our journey to comprehend, assuming we are distant from everyone else in the universe. This drive is essential for the more extensive quest for extraterrestrial knowledge regularly known as SEI. The undertaking includes the assortment and capacity of different transmissions from space, making a data set for future exploration. The information gathered has prompted critical disclosures, especially when Shin Smith, a persevering undergrad at UC Berkeley, began dissecting the transmissions. During his work, he coincidentally founded an inquisitive tight-band radio recurrence emanation at 982 MHz, which was concealed inside the OB perceptions of Proxima Centauri. This intriguing disclosure grabbed the eye of Sophia Schick from Kent State College, who assumed control over the transmission investigation. She commented that this specific transmission addresses one of the most exciting finds of the Advancement Listen project, as it digresses from average examples we have seen before. The Parkes radio telescope works by recognizing signals north of 53-minute terms. During these meetings, the telescope focuses at Proxima Centauri and afterward changes to notice different region of the sky to affirm that any potential transmissions start from the actual star. Sophia made sense of that. During around 3 hours of perception, a transmission reliably returned during 5 of the 30-minute stretches when the telescope was focused on Proxima. On the other hand, when the telescope moved away, the transmission evaporated, bringing up fascinating issues about its source. This builds up the meaning of the disclosure. Space expert Dear RIT of the College of Pennsylvania featured that noticing the kind of transmission that doesn't come from Earth firmly recommends the presence of cutting-edge innovation. Continuous investigation of these transmissions means to affirm their extraterrestrial, beginning with the help of the James Webb Space Telescope, which is being coordinated towards Proxima B. Researchers accept it might before long identify fake light from the planet, giving extra proof of a potential civilization. Abraham Curve from Harvard College underscored that assuming Proxima B radiates counterfeit evening time brightening coming to 5% of the regular daytime light, the James Webb could distinguish this light with a 85% conviction, which would be pivotal. Proxima B is altogether more modest and dimmer than our Sun, which influences the arrangement of its tenable zone. This one-of-a-kind trademark implies that the livable zone is a lot nearer to the star than it is in our nearby planet group. Proxima B circles a ways off of around 4.5 cosmic units from Proxima Centauri, prompting an orbital time of around 11.2 Earth days. Proxima Centauri is known for its dynamic nature, delivering fierce sun-powered flares that could present difficulty to the likely tenability of Proxima B. Moreover, the exoplanet's closeness to its star brings about outrageous temperature varieties, with the daytime side being singing warm and the evening time side freezing cold. These radical temperature changes could have significant ramifications for the planet's capacity to help life. Proxima stands apart as the exoplanet that dazzles the consideration of cosmologists and scientists because of the abundance of information accumulated about it. Anyway, it isn't the just exoplanet that displays Earth-like circumstances that might uphold life inside the smooth-way world alone. A sum of 55 possibly livable exoplanets have been affirmed, with a lot more at this point to be found as our innovation propels we keep on looking for and recognize these far-off universes. For example, in our adjoining Andromeda system, which has aspects tantamount to our own, there stays immense potential for tenable or occupied planets. In addition, inside the bigger design of the universe, superclusters of cosmic systems present much more prospects. The smooth way has a place with a neighborhood bunch, a group of around 40 systems, which is itself part of the neighborhood supercluster containing approximately 100,000 universes. Amazingly, gauges proposed that there are around 10 million superclusters all through the universe. This prompts significant thought. Assuming the smooth way is generally humble in size and as of now has 55 affirmed possibly livable planets, simply envision the innumerable tenable planets, or even those facilitating life across the limitless field of the discernible universe. The meaning of finding exoplanets lies in its capability to extend how we might interpret our spot in the universe and to respond to major inquiries concerning life and presence on different planets. The continuous investigation of exoplanets permits us to explore the huge variety of planetary frameworks and investigate the chance of new types of life past Earth. Besides, these disclosures can improve our perception of how planetary frameworks structure and develop over the long haul. The ramifications for the quest for extraterrestrial life are significant. Exoplanets act as basic contender for holding on to life and can give important data about the circumstances essential for life to flourish somewhere else. Eventually, the investigation of exoplanets empowers us to test our current hypotheses and models in regards to the arrangement and development of planets and heavenly frameworks, fundamentally propelling comprehension. We might interpret the universe, and our job inside it, investigating the tremendous breadth of our universe, has consistently ignited human interest, pushing us to look for replies about our reality and the potential for life past Earth. The journey to find new universes isn't simply a logical undertaking, yet a philosophical one that challenges how we might interpret life, livability, and the actual universe. As we adventure further into the domains of room investigation, our advances and procedures keep on developing, empowering us to acquire experiences that were once unfathomable. Late missions to different divine bodies inside our nearby planet group have given significant information about planetary conditions. For instance, the Mars wanderers have uncovered proof of old waterways and lakes, proposing that the red planet might have once held on to conditions appropriate for life. Moreover, missions to the external planets, for example the Juno rocket circling Jupiter and the Cassini test concentrating on Saturn, have uncovered complex insights regarding their climates, magnetospheres, and moons, some of which may likewise hold the potential for life. The variety of these conditions features the horde manners by which life might actually emerge. The quest for exoplanets has additionally upset how we might interpret where life could exist. Kepler's central goal alone has found a huge number of exoplanets, a considerable lot of which dwell in their stars' tenable zones. These disclosures have extended the meaning of what comprises a possibly tenable world, permitting researchers to consider different factors, for example the presence of moons, barometrical creation, and geographical action. One fascinating part of the investigation of exoplanets is the idea of biomarks, pointers that recommend the presence of life. Specialists are creating strategies to break down the environments of far-off universes, searching for gases like oxygen, methane, and carbon dioxide that could demonstrate natural cycles. The potential for utilizing telescopes like the impending Very Enormous Telescope L or the Roman Space Telescope to look for biomarks is producing fervor in the cosmic local area. These perceptions could change how we might interpret life's conveyance in the universe. Notwithstanding direct perceptions, the area of astrobiology has get some decent momentum, analyzing the circumstances that could permit life to flourish somewhere else. Researchers are contemplating extremophiles, creatures that can get by in outrageous conditions on Earth, for example remote ocean aqueous vents and acidic lakes, to more readily comprehend the constraints of life. This examination illuminates our quest for life in places recently considered unfriendly. For example, the frigid moons of Jupiter and Saturn, Enceladus and Europa specifically, are of extraordinary premium because of their subsurface seas, which could hold on to microbial life. As we look toward the future, colonizing different planets turns out to be progressively conceivable ventures pointed towards sending people to Mars. For example, SpaceX's Starship and NASA's Artemis program imagine a maintainable human presence on the moon, and past these drives not just expect to push the limits of human investigation, yet additionally to lay out an extremely durable human traction in space, preparing for additional investigation of the nearby planet group and past. The potential for finding life past our planet brings up significant moral and philosophical issues. What's the significance here for mankind to experience extraterrestrial life? How might we approach correspondence and collaboration with smart creatures? These inquiries are not just speculative, they are pivotal contemplations for future missions, creating structures for moral commitment with extraterrestrial knowledge. Is a subject of developing revenue among the researchers and ethicists the same. Besides the continuous disclosures in the field of exoplanet research, how we might interpret planetary frameworks, the presence of surprising planetary designs. For example, sweltering Jupiter's gas Goliaths that circle exceptionally near their stars, muddles existing models of planet arrangement. These oddities brief researchers to re-examine the elements of planetary movement and the impact of heavenly connections on planetary improvement. The idea of the Goldilocks zone, where conditions are perfect for life, is likewise being rethought. Research shows that life could exist in a more extensive scope of conditions than recently suspected. For example, subsurface seas on frosty bodies could give stable conditions to life, and high energy conditions, for example those found around dark smokers on sea depths, could likewise uphold one-of-a-kind natural frameworks. Public premium in space investigation has developed, altogether energized by dazzling pictures from telescopes and arousing stories of missions like the Constancy, Meander, and the James Webb Space Telescope. Virtual entertainment stages permit researchers to share their discoveries and draw in with the public, cultivating a worldwide local area energetic about stargazing and investigation.